Okay guys, we're going to look today at Chapter 8, Section 1, and we're going to be multiplying and dividing rational expressions. When you see rational, what word should come to mind?
Russian.
What?
Russian.
How about ratio? Okay, ratio. A ratio is something over something else. And how do we deal with it when we have like polynomials on top of other polynomials? And so let's look at one. What if I have 4x cubed onto x squared plus 7x minus 8, and we have it over 12x onto x squared minus 64, and we want to simplify. So like when you look at this, there's kind of like you could look at it and there's two things you could say that you could do. And one of them would be a good thing to do and one of them would be a bad thing to do. What's one thing that you could do with the numerator and denominator? Distribute, right? You could distribute the 4x cubed and then you would get a really long polynomial and then you would get a really long polynomial and then you would be kind of stuck, right? It would be hard to do anything at that point. So did that make things simpler or did that make things more complicated? More complicated. So what we probably don't want to do is we probably don't want to distribute. Does that make sense? What's something else you could do? Like when you see this term in parentheses, one thing you could scream out would be what?
Quadratic.
Yeah, it's a quadratic. All right. And then you could scream out here what? It's a quadratic. So what's something that we know how to do with quadratics?
Factor.
What?
Factor.
Factor. And if we factored them, what's something that might happen?
We could reduce.
Yeah, you might have common terms in the numerator and denominator, right? But even before that, but even before we factor, what are two things that we could deal with even with it in the present form? What? The 4 and the 12 would already reduce. And what else would reduce? The x cubed and the what? X. Will the x squared and x squared reduce? No, because those are part of a bigger term. Only the things that are multiplied, like if you have apple times banana times avocado, those are all multiplied together. You could reduce them, but if you had times avocado plus 1, that plus 1, now you can't reduce the avocado, okay? So let's go ahead and do the reduction. 4 over 12 would be what?
1/3.
Yeah, we would have a 3 down here. And x cubed over x, I would have what?
X squared.
X squared in the numerator. Okay. Now what I should do is I should factor. Okay? What should you scream when you see this, x squared minus 64?
Difference of perfect squares.
Difference of perfect squares. So how would I factor the denominator?
X plus 8.
X plus 8?
X minus 8.
X minus 8. All right? How about this? What would this term and this term be? X and X. Are the signs the same or are the signs different?
Different.
They're different, so I'll have a plus and a minus. So how could I get to x squared plus 7x minus 8?
Plus 8 minus 1.
Plus 8 minus 1. All right? So now, what happens? A little magic happens, right? X over 8 divided by x over 8 becomes what? 1. So now I have x squared over 3 times x minus 1 over x minus 8. Is that good? Yeah. All right. Now there's something that you have to see though. You have to see that when you take something out of the denominator, it leaves a hole, and you can't ignore that. Because we started with this, what is true? Even though this x goes away, what is still true even down here? X cannot be equal to, what can we never have in the denominator? 0. So x cannot be what? 0. What else can x not be equal to? What? X cannot be negative 8, and x cannot be, what's the other one, Jaden? What's the other one it can't be? Can't be 8, right? Okay, it can't be 8. Okay. Jaden, why don't you move up here? Just because you're so far back there, I'm afraid that you're not seeing. And so why don't you just start sitting up here, find a more nearby seat, because I think that you'll see better if you sit closer, okay? So these are part of your answer, okay? Now do you see the x is gone, but you remove the x, but what is still true? X cannot be 0 because it started here. So even though you take it out, you still have to track along what cannot be what, all right? Does that make sense? Okay, let's move on. What if I have x squared plus x minus 12 over x squared plus 7x plus 12? What should you be screaming?
Quadratic.
Quadratic. And quadratic. What should I do, Jaden? Factor. Okay, Jaden, help me with the top one, and then Mario, I'll have you help me with the bottom one. All right. So x squared plus x minus 12. Jaden, because that's an x squared, what would go here and here?
X and X.
X and x. Are the signs the same or are they different?
They're different.
Plus and minus. I got to get to 12, and the middle one 1. How would I get to 12? A what and a what?
A 1 and 2.
A 1 and a 2 doesn't make 12.
A 1 and 12.
Okay, a 1 and a 12, would that give me x here?
No.
Okay.
Oh,
Well,
3 and 4.
a 3 and a 4. Okay, would I add the 4 or would I subtract the 4? I got to figure out which one goes where.
You would add the 4.
Yeah, okay, 4 and minus 3. Now, that was really good thinking, but we always should check it just to make sure. That's x squared, and then plus 4x minus 3x is plus x minus 12. Did we put them in right? Yeah, good job, Jaden. Okay, Mario, how am I going to factor this? What goes here and here?
X.
X and x, are the signs the same or are they different?
Same.
Are they plus or are they minus?
Plus.
Plus. So x plus, x plus. How am I going to get to 7x from 12?
Plus 3 plus 4.
Plus 3. You're good at factoring, man. Plus 3 plus 4. Okay. Now, what is happening? A little what? Little magic. That x plus 4 over x plus 4 makes?
1.
What am I left with?
X plus 3 over x plus 3.
Am I done? No. What do I need to write here? Josie, what can x not be equal to?
0.
If I put 0 in x, that's 3 times 4 is 12. That doesn't hurt anything. What can x not be? Think of it this way, Josie. What can this whole term not be, Josie?
Negative 3.
No, the whole term cannot be what?
Cannot be 0.
What?
Cannot be 0.
Right. So, x plus 3 cannot be what, Josie? 0. Therefore, x cannot be what, Josie?
Negative 3.
Negative 3. Okay. Kelsey, what else can I not have in the denominator?
Negative 4.
Okay, that's the right answer, but tell me how you get there. What?
X plus 4 cannot equal 0.
X plus 4 cannot equal 0, therefore x cannot equal what?
Negative 4.
Negative 4. All right. So even though this term is gone, you still have to do this, okay? You still have to do this. It's undefined at negative 3 and negative 4, all right? Let's keep going. Let's keep factoring. Okay? What if I have z squared w minus z squared over z cubed minus z cubed w? All right? So, Tanner, look up here at the denominator and tell me what you could do up there. Is there anything that you could do?
You can
Divide z through w.
You can what?
Divide out z through z cubed and w.
Well, I can't.
Z squared.
There's not. Yeah. What can I factor out of what, Tanner?
C squared.
Z squared. All right. right? I can take z squared, and then what do I have, Levi, inside left?
W minus Z.
W minus what?
Z.
What?
O minus Z squared.
I took the z squared out.
Oh, just W minus 1.
W minus 1. I'm left with a 1, right? Okay. Kelsey, what am I going to factor out of the denominator?
Z squared. I mean cubed.
Z cubed. You were thinking it, your brain was thinking it, but your mouth was saying squared. What am I left with?
1 minus W.
1 minus W. Okay. Now we can do, now what can I do here, Jaden?
You can move z squared to the bottom, or like
So z squared over zq ends up being what?
1 over z.
1 over z. 1 over z. Okay? And now I have w minus 1 over 1 minus w. All right, let's think about this. Is w minus 1 the same as 1 minus w?
No.
Man, but I really wish I could make those simplify, right? Somebody tell me what I could do.
1 minus W. Or it'd be 1 plus W.
No, I know what you're thinking. You're thinking of a complex conjugate or a conjugate for a square root. That's a good thought, but that's not going to work here. What do I wish this one was?
W minus 1.
W minus 1. So this is what I want you to think. I'm going to go 1 over z, and then I'm going to have w minus 1. Okay, if I multiply this by minus 1, I get what? W minus 1. But can I just multiply this by minus 1? No, I've got to do what out here also? Put a minus out here, right? So, if I put a minus here and a minus inside there, it's like I factored out a minus 1, right? Have I changed anything really? No, I have not. But now what can I do? W minus 1 over W minus 1 makes? W minus 1 over W minus 1 makes 1, and I'm left with minus 1 over z. Does that make sense? So if you get close, guys, go ahead, play that trick so that you can get something out that otherwise you couldn't get out. Let's do another one. Okay, let's do another one. I have xy minus 3x over 3x squared minus x squared y. Josie, what are you going to do up here?
Take out factor out X.
Factor out an x. Okay, Levi, give her a chance to say it, okay? Because you know what's going on, but just make sure you give her a chance to say it so she thinks through it. X, so I'm going to have x, and Josie, what do I have left if I take the x out?
Y minus 3.
Y minus 3, boom. Okay, Jaden, what can I do down here?
You can take out x squared.
X squared, and we're going to call it factor. Okay, we're going to factor out the x squared. And Jaden, what am I left with?
3 minus y.
3 minus y. Okay, what's the easy thing that I can do, Mario? X over x squared becomes what?
1 over x.
1 over what?
X.
X. Okay. Now, let's look at the y minus 3 into 3 minus y. Kelsey, what do you think we should do there?
Multiply by y minus 3.
If I multiply by y minus 3, I'm going to get y squared minus 3y plus 9. That's not doing it. What did we do last time?
Multiply by a negative.
Let's say it this way. Factor out a negative 1. Okay? So if I factor out a negative 1, I bring the negative out here, and then, Kelsey, what am I left with inside of there? I'm taking out a negative 1. What am I left with?
Y minus 3.
Well, actually, let's keep it in order. It would be minus 3 plus y. Okay? And you see, if I factor that back in, I get that. Does that make sense? Now, what do I have up here? I have y minus 3. Now, y minus 3 and minus 3 plus y, they're the same, right? So what can I do? Makes 1. So the answer is minus 1 over x. And what do I need to write down? What do I still need to write down? Y cannot be equal to what? What?
Positive 3.
Y cannot be equal to positive 3. Does that make sense? Okay, let's keep going here. We're going to keep going. Let's say I have 5 over 6 times 4 over 15. Tell me 2 ways that I could solve this problem. What's one way I could solve it, Josie? Yes, it would be 5 times 4 over 6 times 15, right? Is that correct? Yes. Is that the best way to work it? No. What's the other thing I could do before I multiply? I could reduce it, right? Because if you multiply it out, you're going to get a huge fraction that you have to then do what to? Reduce. So wouldn't it be easier to do what? Reduce now. So tell me how I could reduce this. What things would reduce?
6 over 15.
Okay, 5 over 15 would become what? 1 over?
3.
What? Yeah, 1 over 3, you're right. Okay, and then a 4 and a 6, what could I take out of the 4 and the 6?
2.
A 2, right? So then I have 2, and then what do I have here? 3. And now I get 2 over 9. Now, isn't that a lot easier than doing 20 over 90, right? Well, 20 over 90 was pretty easy because it's round, but in most cases it's a lot easier to do it this way. All right, let's do another one. We are going to do 4a over 5b times 15b squared over 16a cubed. All right. Kelsey, tell me one way that we could do this. What's one way that we could do this? We could just do what?
Just multiply across.
Multiply across. Would that be wrong? No. Is that the best way to do it?
No.
No. What's better, Kelsey, for us to do?
Reduce.
Okay. Like what, Kelsey, tell me one thing that you see would be easy to reduce. Just one thing.
5 and 15.
5 and 15, I would end up with what up top?
3 over 1.
A 3 over 1.
Oh.
Levi, you tell me one that I can do.
You'd have to take out the b as well.
Okay, but let's do the numbers first.
You'd have a 4 over 1, or 1 over 4.
Okay, but tell me, it's 4 over
60.
becomes what? 1 over 4, so 1/4. You see, take care of the numbers first. We've reduced those. Now what do I need to reduce, Jaden?
A and the B.
Okay, well, just tell me one. Which one are we going to reduce?
B.
B. So I have b squared over b. That's going to become what?
1 over B.
I have b squared over b.
Oh, B.
Okay, in the numerator or denominator?
In the numerator.
Okay, so there's going to be a b. All right. Now I have a over a cubed. Tanner, what does that become?
1 over a squared.
Yeah, you have 1 over a squared. All right, so you're going to have 3b over 4a squared. Isn't that a lot better than what we started with? Yeah, that is a whole lot better. Okay, what if we ran into something like this? Okay, what if I had 4x squared y over 15a cubed b cubed divided by 2xy squared over 5a b cubed. What do I hate and want to get rid of immediately?
That we should divide.
the divide sign, right? Because we don't do, that's baby math. We get rid of that division sign. How would I rewrite this without the division sign?
4x squared 1 over 15 a cubed b cubed.
Okay, now what do I do with this term?
Multiplied by the reciprocal.
Multiply it by the reciprocal, Jaden says, very correctly so. Let's take care of the nonsense of that divide sign right off the bat. Okay, now, Josie, tell me the first thing that you're going to reduce here. The 5 and 15 becomes what over what? 1 over 3. Kelsey, what are you going to reduce now?
4 and 2.
4 over 2 becomes what?
2 over 1.
2 over 1, thank you. And why do I like it when you say 2 over 1 like you did? Because it reminds you where it is. And just putting the 1 down there kind of reminds you what you're doing. Okay, Mario, what are you going to reduce?
The 4 over 2.
We did the 4 over
Or
2.
the x that are
Okay, x squared over x becomes what?
x over 1.
X over 1, we'll just leave it like that, okay? Now, Tanner, what are you going to reduce?
5 and 15.
We did 5 and 15.
8.
Which one, A or B?
B.
B. So b cubed over b cubed becomes what? 1. All right, so we don't have to worry about the b's. Now, what's the one last thing, or I guess we got 2 last things we got to do. What are we going to do next?
The y.
The y? Okay, I got y over y squared. What do I end up with?
1 over y.
1 over y. Okay, the final one that I got to do is a. I got a over a cubed becomes what, Jaden?
1 over a squared.
Boom, 1 over a squared. Okay, so I can't do it anymore. It's 2x over 3a squared y. Is that good? Boom. Okay. Okay, I'm going to work 3 or 4 more problems because we want to do a lot of practice on this. A lot of practice. This is really important. Okay. X squared plus 2x minus 8 over x squared plus 4x plus 3 times 3x plus 3 times x minus 2. So, Josie, tell me one thing that we could do with the numerator and denominator. What's one thing that we could do? You could just multiply across and end up with a huge, ugly term. Multiply across, end up with a huge, ugly term. Would that be wrong? No, it would not be wrong. Would it be smart? No. What's a better thing, Josie? What should I try to do to each one of these terms? How about factor? And then after we factor, we can reduce, okay? All right, Mario, you're Mr. Factor. What is this going to become?
X. And x.
Are the signs the same or different?
Different.
Okay. How do I get to 2 by the factors of 8?
Plus 4 and minus 2.
Plus 4 and minus 2. Okay. Jaden, can you help me do this one? What do I have here and here?
X and x.
X and x. Okay.
And they're the same.
The same and positive, and then what do I get?
3 and 1.
X plus 3, x plus 1. Kelsey, what can I do to this term?
Take a 3 out.
That's what I would do. And let's say factor. Okay, factor of 3. 3 onto x plus 1, and then x minus 2. And then what starts happening? A whole lot of what? Magic, right? What's one that's very obvious?
X minus 2.
X minus 2 over x minus 2 makes?
1.
X plus 1 over x plus 1 makes? So I have 3 onto x plus 4 over x plus 3, right? That's way simpler, isn't it? It's way, way simpler. All right. What's that? You okay?
Oh,
All right. Just
Thank you.
all right. Let's work another one. Oh man, this one is going to get ugly.
On that last problem, would we distribute the 3 onto the...
I would not. Thank you for asking. It would not be wrong, but as we're simplifying, it's better to leave things kind of factored out. Okay, good question, Jaden. Good question. Okay. Oh my goodness. R squared over R squared minus 25S squared over R onto 5S minus R. Oh my goodness, why do we hate this one?
Because it's a complex fraction.
It's like a 4-level fraction. Before we try to do anything else, what should we try to do? What would be, yeah.
You just multiply by the reciprocal of the bottom.
And what do we call the bottom?
Denominator.
Denominator.
So you're going to have R squared over R
Yeah.
squared minus
And I'm just going to repeat so that they hear what Levi said is we're going to multiply by the reciprocal of the denominator. So I'm going to have R squared over R squared minus 25S squared times the reciprocal of the bottom, or the denominator. Now you've got me saying it. 5S minus R over R. Okay, is this a lot neater? Yeah. What's the first thing? Well, okay, what are we going to try to do? Like, tell me the next thing that we should try to do. Reduce, okay? But even before we reduce, we should do what? Always. Starts with an F. Factor, factor, factor. The secret to these problems is what? Can't hear you. You're not saying it. Okay, factor, factor, factor. Okay, so I'm going to have R squared. What could I do here? 5S minus R.
Take R and have 5S over 1. Oh, negative 1.
I can't do anything there, right? There's nothing that'll come out, all right? And then I have an R here. I'm going to kind of rearrange it. 5S minus R. What should someone be screaming about this right here?
Quadratic.
It's a quadratic, and what special kind of quadratic, Jaden, is it? Difference of perfect squares, okay? And if you didn't say that, I was going to point here and hope you would say difference and then think difference of perfect square. So what would that do, Josie? How would I factor R squared minus 25S squared if it's a difference of perfect squares? What goes here and here? R. Okay. 25S squared, is that a perfect square? So that would become what? 5 what?
5S.
5S. So it's R minus 5S and R plus 5S. Okay. Kelsey, what do I really want to... Oh, and I had an R here too, right? I'm sorry, I dropped that R. This R is still there. What do I really want to do here, Kelsey, that I got to kind of make happen?
Make it 5S minus R.
Yeah, I make it 5S minus R by factoring out a minus 1. So I bring a minus 1 out, and then this becomes 5S minus R, right? I factor out a minus. So now R squared over R becomes what? R squared over R becomes what?
Minus 2 over 1.
What?
Wait, what? Oh,
R squared over R becomes?
R over 1.
Okay, R over 1. And I still have the negative out here, right? And then 5S minus R makes?
1.
And what do I have down here? R plus 5S. I cannot do anything else. This is minus R over R plus 5S. Okay? Is that good? Everybody happy with that? All right. I'll work one more, and then I'll give you the homework. Okay. I have x plus 3 squared over x squared minus 16 over x plus 3 over x plus 4. All right, Kelsey, why do you hate this problem?
Because it's a big fraction.
Yeah, it's 4 level. So Kelsey, what are you going to tell me to do that will make this more manageable?
Multiplied by the reciprocal of the denominator.
Oh, and she said denominator. Very good. X plus 3 squared over x squared minus 16 times the reciprocal of the denominator would be x plus 4 over x plus 3. Okay. Now, Jaden, what are you going to tell me to do here?
Factor that.
Because it's what?
A difference of perfect square.
Boom, difference of perfect squares. So I'm going to have x plus 3 squared times x plus 4 over x plus 3, that one. And then, Jaden, what does x squared minus 16 become?
X plus 4. X minus 4.
And what's going to happen? Bunch of magic. X plus 4 over x plus 4 makes 1. And then x plus 3 squared over x plus 3, what does that become, Josie?
X plus 3 over 1.
Yes. So then I'm going to have x plus 3. That makes that square go to 1 over x minus 4. Boom. You see that?
And then you do the x can't equal plus 4.
Yeah, well, you would say x can't equal plus 4, x can't equal minus 4, and x can't equal minus 3. You've got to do them all, even the ones that came out. All right? Okay, the homework is, and get this, don't turn it off yet. Get this, the homework is Chapter 8, Section 1, due Monday. Chapter 8, Section 1, 16 through 33, 44 through 50. The bonus is 68. 16 through 33, 44 through 50, bonus is 68. Okay? Go ahead and